Hello everybody, my name is Dimitris Katsafouros. Try repeating that 3 times in a row. This tutorial's discussion topic is all about cinema. Cinema 4D Release 14 has just come out and it has introduced some really nice tools, making our life easier as a result. The tools we are going to talk about are the camera matching tool and the new camera morph tool. This is what we will be creating today. Most of the environment is just one picture, and the rest are some simple 3D objects. So, aside from learning how to camera match our photograph, we are also going to find how useful the camera morph tool can be. In just a few steps, we can set up an animation that is easily adjustable and quick to set up. Camera mapping works by projecting a photograph to some simple 3D geometry. We use really simple geometry, but through the texture work mapped on the geometry, we can trick the eye that there is a lot of complicated work being done in the background. Let's see some camera mapping examples. This one is really simple to set up. There's a lot of work involved in Photoshop to create the different layers for each object, but the actual work in Cinema is really simple. As you can see here, there are a lot of different layers separating each object to its own layer. But if we go to our cinema scene, you will see that the geometry is quite simple. For example, the object describing the bridge is just a modified plane object with some extrusions for the wires of the bridge. The same goes for the steel fence in the foreground. The rest of the scene is just a few modified cubes or cylinders, etc. Really easy stuff. Or take this example here. The models are mostly cubic-based variations. And some planes for background elements. Camera mapping was really easy to do in Cinema, but it had one small problem. You had to play around with the camera a lot to match the picture with the geometry you were going to end up with in the end. For example, for this scene, I would have to create a camera and a few quick stand-in objects. Move it around in space, tilt it, find the right camera lens settings, and so on and so forth. Before, if you weren't careful, you could end up with a geometry that was stretched a lot or was too far away from each other, and as a result have all sorts of animation problems later on. With Release 14 it couldn't be easier. Camera matching deals with all that stuff, and now you can just concentrate making your work look good. But before we get into cinema territory, let's prepare our photograph a little bit. In this photograph, we just need to make a few small adjustments. For example, we need to have a clear layer of the right wall without the lights. We need a clear wall because the camera move will reveal these spots, and if there aren't any, the effect will be ruined. For example here, I had to add some visual information to make sure that when the camera moved, we would see something and not just a blank, empty space. We don't want to erase the light objects completely, so we're going to create our clean wall on a new layer. To create that information, we can use a lot of different tools from Photoshop's toolbox, but the easiest would be the patch tool. Just select the area you want to get rid of, and then drag your mouse to a clean area of the picture. And that's it. Now do the same with the rest of the lights. The next area that needs our attention is the wall at the far end of the subway. We need to make sure that there's a lot of information around it so that when the camera moves, we will see some sort of information there. The easiest thing to do would be content-aware filling. If you don't have any of the latest versions of Photoshop from CS5 onwards, you can use the traditional tools like the stamp tool. Make sure it looks good, but don't spend a whole lot of time on it. Let's see how we can accomplish that with the content-aware fill. Copy and paste the selection of the wall on a new layer. Now, we only need to expand the wall just a little, so make a selection of the wall, inverse the selection, and reduce the selection by holding Alt. Now that we have our selection ready, we go to Edit, Fill, and instead of using the foreground color, we choose Content Aware. We now have a really nice base to further refine the outer sides of the wall. We're not going to do this now, but it just involves selecting the areas you think are good and stamping them on the area you need. Either way, this file will be included, so you can go to Cinema straight away if you want to. The other way you could approach this is with the stamp tool. It's exactly what we would do to refine the content-aware area we created before. So you slowly make your selections and stamp that selection to the area. It's a slower process than the one we used before, but it's also a good idea to familiarize yourselves with the tools that aren't so automated, since these are the ones that will save you the most on difficult projects. The other thing we need to do is tone down the lights at the ceiling. Some information is lost there, and on top of that, we are going to use CG lights in these areas, so we will get back that effect in cinema, but in a more subtle and controlled way. The patch tool is the way to go again. If you feel more comfortable with another tool, use that, but there are instances where one tool works better in a certain type of situation. So, now that we have our file ready, let's dive into Cinema and start creating our virtual environment. We start by creating a camera in our scene and making that camera active. All the new camera matching stuff work with the addition of a tag. So right-click and choose Camera Calibrator. The tabs that interest us the most and make camera matching a possibility are the Image and Calibrate tabs. So let's load up our image. As you can see from the grid behind the picture, our camera is way off. Let's see how we can fix that. We need to somehow give some information to the program where each plane is in our picture. If enough information is given to it, Cinema will be able to figure out what lens is being used, the rotation of the camera, and a whole lot more. To do that, we go to the Calibrate tab, and there you can see we have three options: add a line, add a grid, and add a pin. By adding lines and grids, we can define the X, Y, and Z space, and basically help Cinema figure out the rest. The pin option is only used at the end of the whole procedure and is there for scaling purposes and object positioning. You can use either lines or grids to define your space, or both. I tend to use lines more, but that's a matter of preference, so do whatever suits you best. A lot of people use grids first and then further refine their result with the lines. But it makes no difference, so choose what you think will work best for you. Let's start. Let's define the Z space first. Add a line and place the endpoints on the points that better define the Z space. As you can see, Cinema magnifies the area where our mouse is to help us with the placement. In very detailed pictures, you could enlarge that area even more by going to Settings and changing the zoom value. We'll keep it as is right now. When you feel that your line is correctly placed, shift-click on the line and click twice to assign that line to the Z-space. You can change the XYZ assignment anytime you want by doing the exact same thing. Shift-clicking cycles through all the axes. It goes from X to Y and finally Z. You can easily distinguish between each axis through the line's color. X has a red color, Y green, and finally Z blue. As you would expect, one line isn't enough to define the Z-space, so we need more lines to have an accurate reading. That's not a problem though, since the Z-space is clearly defined in the picture. So let's carry on doing that. Add a line and define the opposite side of the ground. As you can see, the Z vanishing point has turned from red to yellow. It's not solved yet, but Cinema lets us know that it has some information about the Z-space. Let's follow the same procedure we did before for the ceiling. Cinema already figured out that this belongs to the Z-space, so it automatically colored the line blue. You can also see that the vanishing point turned from yellow to green. The value on the right gives us the accuracy of the solve. Let's do the other side as well. Now that we have Z ready, we can move on to the Y-axis. Here again, our job is really easy. We're going to use 4 lines to define the Y-axis. Shift-click twice to assign the line to the Y. Do the same for the opposite side, and also for the side of the walls that are far from the camera. The Y-axis is partially solved with 2 lines, and Cinema has enough information to solve the X-axis through Y and Z. But to improve our accuracy, we're going to keep on adding lines. With our last point for the Y line, we can see that all of the axes are green-lit, even X, even though we haven't assigned it any lines. The other thing you will notice is that Cinema automatically adjusted the camera to match our picture. And as you can see, it's quite accurate. If you move any of the lines, you will see the grid also moving. Now, all we need to do is add a pin, and we're all set. Let's quickly test out if any object looks good on the photograph. If you add a cube straight away, you will see everything vanishing. That is because the image we're using was just a helper for the camera match. In order to see the picture in our scene, we need to press this button here, which automatically creates a background object and assigns a material to it. Since we're here, we will also press the Create Camera Mapping tag to create the texture all of our camera mapped objects will use. For example, the walls of the subway will use that texture. Now, let's add a few cubes and move them around to see what we have achieved so far. As it seems, everything is looking good. So let's start adding our walls. We're going to use simple plane objects. There's no reason to make things complicated. You could even lower the detail of the plane object. A simple polygon could do the work. Once we have our 4 walls ready, we need to assign them the textures of the photo. To do that, we will use Projection Man. You just drag and drop the objects onto the PSD and choose the layer we want. For our walls, we will choose the layers without the lights and with the slightly extended walls. Now let's see what we have done. Disable the camera so that we can move freely in our environment. Pretty neat. The camera we created at the beginning will only be used for our texture projection. Whatever movement or scene framing we need will be done with other cameras. So it might be a good idea to protect our camera with a protection tag. Now let's start adding a few more objects to define the stairs and the lights. These can be really simple objects like cubes that are slightly rounded or cubes that are slightly extruded. Don't go overboard with the detail. You can really get away with a lot through camera mapping. On the stairs, for example, we've used a simple cloner object that clones one rounded cube. And then we drag that cloner to the PSD, and that's it. Keep on adding more simple objects to define your scene even further. By the end, you will have something that looks like this. And we got all that just from a simple photograph. At this point, we can add a few objects to make things a little bit more interesting visually. This is the part where you can let yourself loose and add all sorts of crazy things. So I'm leaving this up to you. This is what I came up with. As for the text, we can use some simple MoGraph effects to make them appear out of thin air. First, write up the phrase you want with MoGraph text. We want the letters to be invisible at first, and then scale up and come to life. To do that, we will use a plane effector. We don't want to affect the position of the letters, so just disable that and enable the scale option. We want a uniform scale, so enable that as well. We want to start the effect when the effector passes through the letters. Set the fall off of the effector as linear, and rotate it to the right side. Now, when we try it out, nothing happens. Set the transform mode to absolute, and let's try it one more time. It works now, but it's the opposite of what we wanted to do. Go to the fall off again and choose invert. Let's give it a go one more time. It seems to be working great. Now, let's quickly set up a couple of keyframes to see how the animation looks. I'm control-clicking on the values I want. The animation looks good, but it's a little bit stiff. One great way to spruce things up is the delay effector. With the MoText enabled, select the delay effector. Now, if we set the mode of the effector to spring, let's see what happens. Great. Now we could lessen the effect a little bit more to make it less cartoony. Whenever you're ready, copy all those elements to your scene and quickly test it out. You should probably apply a different effect to the rest of the type to make it a little bit more varied, but that's up to you. Here's what I came up with. So now that our scene is ready, we can move ahead with our camera setup. And now this is where the fun begins. As we said before, the Camera Morph tool works by cycling through already existing cameras. So we basically need to set up a few cameras that frame our action really well, and then use the Motion Camera tool to just set a couple of keyframes. The motion I'm thinking about is have the first camera work as an establishing shot of the whole scene, then zoom into the logo building up, stay there for a while, and then zoom past it to the end of the corridor. So, let's do that. I would like a dynamic camera move with lots of weird angles. So I'm thinking it'll be interesting to have a camera with a really wide angle lens. So instead of having this, we could have something more like this. Looking good. Now that we have our first camera, we can move on with our second one. This camera will frame our text. It's also a good idea to have another camera facing the text, but from a slightly different direction and angle. Our fourth camera is preparing the motion for the last camera, so we should move it away from the logo and a little bit higher. And finally, our fifth camera should point at the end of the corridor, where we will fade to black in post. Now that we have our cameras ready, we just need to switch between them. Select all your cameras and choose Camera Morph. This will create a new type of camera that has all of our selected cameras added. Make sure your cameras are in the right order, and if they're not, just drag them to set them up correctly. Now, if you use the Blend Morph, you can see the animation being generated by our previously set up cameras. Isn't that cool? The great thing about this is that you can continuously change your settings of your cameras, and the Morph camera will update with the new setting. All we need to do now is just set a few keyframes and we're all set. Now you can further refine your scene in your favorite compositing program. I tend to do that a lot. Since I know the effect I want to go for, I leave the animation as simple as possible so that I can speed it up or slow it down in post. It depends on the project though. The same goes for other effects like motion blur and depth of field. Aside from the fact that these will impact render times, it's nice to have them applied at post, since if there's a change of mind from you or your client, you can just disable the effect rather than re-rendering the whole animation sequence again. And that's about it. Hope you had a blast playing around with camera mapping and the new Camera Morph tool as much as I did. Can't wait to see what you guys come up with. Until next time, happy rendering!